have Ryan here today. I'll come back to him in just a second. Let me just give you an overview of what we've got going on. So Ryan's talking this week. I'm really looking forward to this talk. It's going to be very interesting. And then next week we're going to be talking about successful failure. So how to fail in ways that aren't catastrophic and are actually pushing you forward instead of setting you back. I'm not sure that this particular picture is an example of that happening. This may have been a much worse failure, but we're going to look at some engineering examples, including a very big engineering failure in downtown Kansas City at what is now the Sheraton. I think it was the Hyatt at the time. Anyway, it's going to be very, very interesting. Some interesting things from an engineering standpoint and the takeaways for software. I think it's the next week after that. David Kopech's going to be talking to us about navigating open source licenses. So just a big overview of how that works and making sure you're aware of all the ins and outs of that. He's a professor of computer science at, I forgot the name of the college. But anyway, that's going to be an interesting talk. And then a few weeks after that, Gary Groover is going to be talking to us about leading large software organizations. Should be some very interesting takeaways there. And then we've got Steve Pereira. I'm going to be talking about mapping your path to performance with flow engineering. So those are the things we've got coming up. Excited about these things. Got some others that are coming on the schedule that I haven't got everything done for, but be watching for these invites coming out here pretty soon. So back to today, Ryan Latta is going to be talking to us about test-driven development and how to introduce it, even if you're not somebody that writes code. So I'm really looking forward to this talk. Ryan and I met. We were trying to figure out what we met at. It was some conference somewhere, and got to know each other there. And I've enjoyed hearing his talks at different places. Stuff, always gotten a lot out of it. Ryan lives in Arkansas and has some very interesting beekeeping stories, including horrible slugs and things taking over his garage. So those may not be a part of this, but if you ever get Ryan at a conference or something, you might ask him for some of his stories. They're very entertaining. So with that, Ryan, I'll turn it over to you. Thank you so much for being here today.
Thank you. So I'm going to go ahead and start sharing. And this will be the last time you have to look at this ugly mug for the talk. I will say that as a part of this, I've rehearsed this talk a bunch of times, and I've got to say that I've got to move pretty quick for this talk. I've done the talk a bunch of times, and it either comes in at like 45 minutes or like an hour 10. So I'm going to have to move pretty quick. I won't be able to hear anything while I'm doing the talk because I'm not going to wear, well, I can wear my headphones. Y'all can't see me anymore, I think. So that's fine. But I'm going to go through this talk, and we're going to go through how to introduce test-driven development, even if you're not technical. So a really quick intro for me. This is me. I'm Ryan. I'm also somewhat infamous for another picture of me eating a squid that no one can figure out that it's a squid. But I've been given enough grief about that I've slowly transitioned away, and I'm not happy about it. I have a website where I write pretty frequently. I also have a LinkedIn. That's the best way to get a hold of me. And that's all I'm really going to say about myself. If you want to know more, you can talk about it later for questions. So what I wanted to talk about, why TDD in particular, of all the other technical practices, and why would I want to try to address this like extra burden of saying I'm not technical, how would I deal with the technical practices? Because TDD, in my experience, it's been one of the most impactful development practices I'm aware of. I've been able to use it for years. I've been able to try most development practices, explore most of the principles people hold on to, and TDD just keeps delivering far better than most others. And so I wanted to make this practice approachable for non-technical people, because I feel like we have in our industry where maybe you're an Agile consultant, maybe you're a manager, maybe you're all this stuff, and you're trying to create a good environment for work, but it's sometimes like we've created this great environment, but we're never going to talk about the fact that our software developers are still typing with their feet, and they should be typing with their hands. And so I feel like it'd be good if we could begin to dive into some of the where the work happens stuff and try to make an impact there, because then you see the bigger picture of we've got the right environment and the right practices, and things start clicking a lot better. So this talk's going to be in two parts. The first part is a bit about what TDD is, but again, it's from the perspective of what do you really need to know if you're a non-technical person trying to introduce it. So I'm not going to cover all the ins and outs, the nuances, and why it's good and why it's bad. There's plenty of other people who have done that. It's mostly going to be about what you need to know as a non-technical person to introduce it. And then the second half will be the actual approach to introduce test-driven development. And I think Mark mentioned the questions. Just go ahead and put them in the chat. I'll try to keep an eye on it, but for this, because I'm so boxed for time, I'm going to just try to deal with them at the end. So let's talk about what TDD is. Now, test-driven development is typically almost always referred to as a three-step process. Red, green, refactor are the three steps most commonly used. Red and green correspond to the colors your tests turn. Red is a failing test, green is a passing test, and refactoring is just changing the shape of your code without changing behavior. You can think of this like if you were writing a paper and you were editing it just so it reads better, but the meaning is still intact. That's what refactoring would be about. So we do those three steps. So I'm going to talk a little bit about those steps. So starting with red, and red means we start with the failing test because red is a failing test. Now, if you talk to technical folk about test-driven development, overwhelmingly they say they know what it is. And of that group, maybe 20 to 50% will say, and I do it. But if you ask more than that and you go further and say, well, what's your process? What's the approach you take? You will not hear write a failing test or write a test as the first step in TDD. You will hear something like, well, I might do a little bit of design, then I'll do a little bit of implementation, then I'll try to write a test quickly. Which is important to know if you're trying to introduce TDD, because everyone will tell you they know what it is. But if you ask, what's the process? You will not hear, start by writing a test. And there's a reason why people twist this around in their head, which we'll talk about in just a minute. But you should know that that's one of the first obstacles. The first step in TDD is also the first step most everyone will get wrong, is start by writing a failing test. Now, another oopsie in here, if you ask about like, well, let's write a failing test, they'll say, how would you possibly write a test for something that doesn't exist? How could you write a test that tests something that does not exist yet? Is like one of the big mental blockers. And the answer to that is we can write a test for what doesn't exist because we can describe what we wished was true in the final system. We can say, I wish our system looked like this and behaved like this, and I can write a test as though that were true. And that works just fine. And I'm going to show you this in a minute in a demo. But that's it. We write the test. Nothing exists yet. The test will fail. So we have a failing test. That's the first step. Now we move on to green. Make the test pass. Now you might think, well, surely everyone gets this step right, but again, we have more problems. And this is a sort of a bigger, interesting issue that pops up. So if we're going to make the test pass, we want to make a test pass as minimally as we can, not like write all the stuff and then we have a test. We want to say, I wrote this failing test, and now I want to make it pass, but I want to write as little as possible to do that so I know that only the changes I put in directly map to the test. If I have more than what the test is actually leveraging, then I don't really know much about it. Those are like extra things that could go wrong and I don't know about it. So we kind of want to keep it like in a really tight one-to-one mapping of this test with these changes always work. So that way I know with confidence that I'm making the right steps all the time. So most technical folk will kind of struggle with this as well because the way most developers work is they basically wind up looking at their code and building this big, complicated mental model of it. They reproduce how it works in their head. So they're reading code, they're following the paths through it, and they're getting a good sense of how it all really behaves. And at the same time, they're cooking up their changes in their head and how that should look and what the design should be, and they're plugging it all in and seeing if that keeps turning right in their head. And then when they feel good about it, they start typing out their answers. So the typing is like the last step for software development for most people. Like a lot of the stuff's happened in their head by then. And so we have this huge lump of everything in our heads about the model and what the changes need to look like, and that's there. And when we say we're going to make the test pass as minimally as we can, that's like a tiny fraction of the huge lump that's in their head. And for most software developers, their instinct is to do it as like one big shot. It's get everything that's in their lump in their head out. And so when we say just do the tiniest little bit, they're not used to splitting up that abstract lump in their head into tiny pieces. And so they tend to want to over implement. They want to write more than what their little test covers. And when this happens, we introduce a lot of extra things that could go wrong or make tests pass or fail for strange reasons. And all of this leads to different variables existing. And when there's more variables existing, that leads to longer debugging and troubleshooting times when things go wrong. And so in a perfect world, we have our failing test, which is for one thing that can go wrong and one change, which is the thing that needs to go right. And because it's just one-to-one, we instantly know what the problem is if there ever is one. That's ideal. And so we want to avoid this concept of, I call it free fall, where we have more stuff than we have tests that cover it. We don't have that safety net anymore. There's no test that will change from red to green with that code. So that's the bad side about over implementing with TDD. We kind of keep it in really tight, small circles, loops, and you'll see that in just a second. So moving on to refactor. Refactoring, like I said, that's changing the shape of the code without its behavior. This is a really important core practice for software development. It's kind of how we fight against technical debt and just entropy and attrition in our systems. It's one of the best tools we have. So what goes wrong here, you might ask? Well, this is where I might want to get on a soapbox a minute, but in general, what happens is most developers skip the step completely. And I don't fault them for this. This is, to me, a learned behavior that unfortunately most software industry has just decided that fast is the same as good. And so anything that comes at the cost of speed, we tend to defer it. So we talk about velocity, we talk about let's schedule tech debt later, let's catalog as a tech debt, let's deprioritize it. Why did we spend time on that? We took too long on it. And so all this sort of like negativity or questioning this sort of like good habit teaches developers that you shouldn't do it because you're going to be told no, or you'll be told that you shouldn't be wasting time on it. So they naturally see refactor, they naturally skip the step and move on. And so this is one of the most important steps in the process, because this is how we would say, even if I don't like what I did for my test or my implementation, this is how I clean it up. This is how I keep things nice and tidy, is the refactor step. And if we constantly skip it, we can make a mess of things just as fast. So this is the other step we get wrong typically, is we skip the refactoring step. So that's it though. This is all I need to tell you about TDD for the case of a non-technical person dealing with it, because it's really about the things you're going to hear and see, not all the ins and outs of it. One of the nice things about TDD is it's a nice little feedback loop. It takes care of itself. The more you do it, the more it teaches you, the more it reinforces itself. So if you can just get it started, the rest tends to follow. And the other part about explaining just this process really quick is I want to kind of point out that it's not as simple as saying TDD are these steps, because everyone thinks they already know what it is, but there are things that are going on behind the scenes in that I think I know what it is that you will have to address. First is misinterpreting the steps because it's incompatible with how they work. And then the sort of going too far or skipping steps, all that tends to weaken the benefits of TDD. Now, I'm going to do something crazy. I'm going to actually show you what TDD looks like. I'm going to do it live. So something will go wrong because that always happens. And even though this is a talk for non-technical people, and I'm going to code in front of you, I know, this isn't about you understanding the code that I'm writing. This is about you getting a feel for what it's really like. So I want you to not pay attention to the code I write so much. If you can, that's great. But I want you to mostly keep an eye on how long this really takes, the overall practicality of the technique. Do you think that it tends to work out, or does it just seem silly? And the kinds of decisions that you're hearing me make as I do this, because these are all things that will help you when you try to talk to someone about giving it a shot. So with that, I'm gonna change this out real quick. Let's see.
How many?
All right, are we sharing again? I think we are.
Yes, looks good. And Ryan, just so you know, you actually are a little box up in the corner, so people can see you.
Uh-oh. Okay. I'll look at my camera and not all of you then.
No, it's fine. You're doing great.
All right. Okay. So, and now if anyone really wants to see how long this takes, you can time me for this. I don't know if anyone cares that much, but you could. Okay, so I'm going to do TDD, and I need a little project to work on. And my little pet project that I use for basically any time I do a new technical thing is I like to build a vending machine. And so that's what I'm going to do. And so the first behavior a vending machine has that I'm going to deal with is accepting money. So I'm going to start by writing a failing test. Hopefully my clickety-clackety keyboard won't be too bad for y'all, but here we go. Now, if you're paying attention, that's actually the first test run, but that just protects me from typos. So I'm eliminating all the variables about me making typos there. So first test, and this is a handy little tip. People starting off with TDD often look at a screen like, what on earth would I write a test for? Nothing exists. So they get stuck, like, what should I write? One of the easiest tests to start off with is what I would call the null test or nil test. Null in software is basically the absence of a value. It's undefined, it's unknown, it's a void. It's got nothing. And if you can imagine, code trying to run on like an undefined thing tends to go badly. Is there a problem with the sharing?
I'm able to see it. Most of it is blank.
Yeah, I can see it just fine.
Okay.
Now mine's back.
Okay.
That's
Awesome.
yeah. Must be mine.
Okay.
Sorry. Carry on.
Well, let me know, because there's a few things I might be able to try to fix it. So I'll try to keep an eye on it. So the null case is easy because so code operating on something that's bad or undefined tends to blow up in our face. It crashes, it causes exceptions, and every developer lives with this problem. We're very familiar with it. It's a everyday deal that we handle null, and so it's an obvious case for us. But also it's conceptually simple because if you get nothing, typically your code should do nothing. So it's a do nothing case. So it's a really easy first case to start because it's conceptually super easy. It's also really well traveled, and that's what I'm going to start with. So I'm going to start with a null case. So it should do nothing if it receives nil money. And nil is just the convention for Ruby, which is I'm writing in, but it doesn't matter for any of you. Okay, there was a pass. This is going to bother me. I've got to do something about that right now. Oh no. Okay, still good. Now I'm in the middle of my test, so I'm going to write what I wish was true about my code. So I'm going to say I have a machine. The machine can accept money, and I'm going to give it that nothing. And I expect that the machine's current transaction, where it would display how much money's in it, to be nothing, just to be zero, because nothing should have happened. I'm going to run it and it should fail. I have a failing test. Whee! Now, it's going to tell me why it failed, and I'm going to pay attention to it. So it says, hey, that thing vending machine that you wrote doesn't exist. So, okay. And now I'm going to go through the process of making it pass as simply as I can. So now it says, hey, accept money doesn't exist on your vending machine. Okay. Now it says current transaction doesn't exist on vending machine. I can do that too. Now it says, you told me I was going to get zero, but you gave me nothing because my code does nothing. I can do that too. I'll give it the thing it expected. And now I've got a passing dot. So I've got my red and my green. Now I could refactor, but I'm not going to because I really haven't done anything yet. I don't have an opinion about how to make this any better. I'll do that, and that's it. So now I'm going to move on to my next test. So I've done the nothing case. Now I'm going to do the something case, the what should it do? So it should accept money. I'm going to give it $1, and I expect to see that it has $1 in it. So I'm going to run it, and it should fail. It said, yeah, I thought you were going to give me $1, but it says nothing, and that's because I basically forced it to always say nothing. So now I'm going to make this test pass. I'm going to have to write a little bit of code to do it, so I'm going to shut up and do it so I don't make mistakes too many. Okay, so I've done something quirky here. The test I was writing passed, but the first one failed, and that's because I'm no longer handling that nothing case. I didn't write that code, so I flopped backwards, and this happens sometimes. So I'm going to make it pass. Yeah. There we go. So he said, hey, if the money's nothing, just get out of here. Don't do anything. And we pass. Second passing test. Okay, refactoring. I'll do a little thing real quick because I'm repeating some stuff. So we'll do this just for fun. So that should be fine. Get rid of those. I don't have to repeat this anymore. And we're still good. Okay. Test number 3. So let's do it. How about I can put multiple bits of money at a time? Vending machines can do that. So here we go. I'm going to do this again. Accept money. We'll give it a, let's get down here so you guys can see that. We'll do. I put in $1.25. I should get $1.25 back. Now, this test passes. This is not a good thing to me. I want to see the test fail. I want to see it fail because otherwise I don't know why it's passing. It could pass for a lot of reasons. If I don't see a failure first, then I can't correlate the failure changing to what I've done. So I need to force a failure to happen so I can be sure of it. So I'm going to say, I'm going to give it the wrong thing to expect, and it will show me what it actually did. So here we go. And it said, hey, this is the thing you asked for, which we know is wrong, but I'm forcing it to fail. And it says, no, I actually did calculate it's $1.25. So now I know it's doing the right behavior because it's told me that's really what it's doing instead of assuming that green meant it's all good. There could be a lot of reasons why it could pass that don't mean it's doing the right work. And by seeing this, now I can confirm it. So now we're good. Refactor. Nope, I think I'm good here. Now I'm going to do one last test case. And I'm going to shut up for this one and just do it. Just do it. I'm not going to say a word about it, and I'll tell you what I did in just a minute. Okay, done. I'll do the refactor in just a minute. So what I just did is said we shouldn't accept negative money, which can happen in the real world, but this is code and numbers exist, so negative numbers could exist. So I protected the system from it by saying, if that happens, throw up an error so I can handle it the way I want. And I've made it do that. So that's the last test case I'm going to write, but I'll do one last refactor. And my refactor here is going to be that I don't like that I'm doing all this stuff checking my money when it should be about just accepting the money. So I'm going to move that somewhere else so I can do all the checking somewhere else. So we'll do that. Now, if any of you are technical and you watched me do that, that probably seemed as completely backwards to how you would try to do it. But if you think about why I did it with TDD, and I always had those tests backing me up, so I never introduced a problem, that's why I did it. But this is a thing you learn with practice. Okay, so at this point, I have a vending machine that can accept money and handle several cases of invalid money. I have tests to prove it, and my demo is now done. Like, this is it. I've done my demo. I've written 4 tests to basically do a fair amount of the behavior for accepting money. So with this, I'm going to go back to my slides. But while I do this, the real question for everyone is, think about what you just saw. Was this did this seem reasonable? Did it seem practical? Did it seem like it takes too long? Did it seem like there's still lots of things that could go wrong? Just form an impression about this process and what it did and the decisions it made me come up with and how I've started to create a system. Do you think I could keep going with this process and build out a vending machine? So let me fix this real quick. Okay. So now with the demo, and now we know what TDD is, it's time to talk about how to introduce it. And again, this is all really to be like, you don't have to be technical. I showed you the code just so you have this in your head about what it could look like. Because anyone who does something for the first time, there's going to be struggles about, you know, we don't have a skill set yet. We may not be in an environment that's good for it yet. And so there's going to be struggle with it. And I wanted to show you what it could look like. Yeah, we'll talk about that in a minute. The example that someone just put in about like the next objection is like, that's a cute example, but it doesn't work in the real world or real enterprise code, and I'll deal with that. But I want you to see what it looks like in terms of pace, in terms of decisions, in terms of practicality, because first contact, second contact won't be that smooth. It won't be that easy. But if you do know that it could get to that, then it might be worth developing the skill and worth altering the environment to make it that good. I know for me, when I started off, when I was first doing TV, I didn't have a good example to learn from, so I just kind of struggled my way through it. And then I finally saw someone who was really, really good at it, and I was like, that's it. That's what it's supposed to look like. And it changed how I began to develop my skill set with it. So it makes a big difference to have that kind of counterpoint. So how do we introduce it? So the first thing we need to do is talk to leadership. This is a pretty easy conversation in my experience to have. There's two types of leaders, and I'll like technical leaders and non-technical leaders. I'm going to address the non-technical leadership first. Technical leaders, you'll basically deal with the same things you would as if you were talking to a developer, because they'll have the same basic objections. So for leadership in general, the idea is that you want to present this as an experiment. We're going to try TDD and see what it does. Take a couple months. There'll be a dip in productivity because we're going to learn and try new things. But what's the benefit? Well, the benefit that I like to talk about with leaders is that you can reclaim a lot of budget and time. And this seems a bit counterintuitive for a lot of folks, especially technical folks. But what I like to do is I like to go into these conversations, and it's not even that I need this often, but I like to be prepared. And I like to show up with some data around a defect rate. And defect rate is just a ratio of the bugs created to the work completed. And that turns into a percentage. If you do calculate it, you'll probably want to double check or triple check your math, because it's usually a number much higher than anyone ever assumes it will be. In my experience, this number ranges from 60 to 120%. And that would mean that if it's 120%, that means for every work item someone completes, there's a 120% chance they created a bug too. And when you present that number, testing triangle, yeah, okay, we can do that. When you present that number, it's one of the best ways I know to people to have that sort of visceral, like now all these talks about bug counts and how many bugs we close, like that's hard to have a feeling about. But now when I see that we are doing work and we're creating that many problems as we work, that hits home differently. And when we talk about TDD and like, yes, this can help reduce this number, those are bugs that we're not finding, catching, triaging, and dealing with. And we usually don't get to pick what kind of bug we get. We don't get to pick that it's a trivial bug where it's a typo on a screen compared to a bug that causes a customer to leave a system. We don't get to pick which ones exist. And so we can directly say that by attacking this defect rate, we can reclaim the budget and time that was otherwise spent on dealing with all of those problems that are self-created. Most every leader I've ever talked to will absolutely sign up for this. They'll be like, yes, go do it. What do you need? This is not a hard conversation. For technical leaders, like I said, their interest will be something else. And I'll address that in just a second. But we want to talk about this and make sure everyone's cool with it. No surprises. And now we're going to go find a champion. And the work to find your champion and talk to them is the same. You're going to have to do with the technical leaders as well. So 2 for 1. I missed that one about that, but I'll keep going for now. The champion you're looking for is got 2 main qualities. One is that they're respected by everyone on the technical team, and the other one is that they're well liked by everyone on the technical team. I'm not saying that they're senior. I'm not saying they're a tech lead. I'm not saying any of that. I'm saying that they're well liked and respected, because they will be working side by side with the technical folks as they struggle with learning TDD and struggling with the environment they're having to learn it in. So if there are people that are listened to and well liked, that tends to go a lot better. And you're gonna have a conversation with them. You're gonna have to talk to them about TDD and this idea that you're gonna do an experiment. And it's very likely they're gonna raise a series of objections. So the first objection is TDD is too slow. I have measured this a lot of times in a lot of places, and it's just not true. It feels true to most software developers because it looks to them like they are doing a lot more work by writing all these extra tests that they otherwise would not have written. And while that's true in a sense, what's happening is not a one-to-one trade. It's a very asymmetrical trade and therefore not obvious. There's a lot of stuff that happens in the development process that is invisible and unaccounted for that TDD directly addresses. And so that's time you gain invisibly. But then on the long tail, you also stop dealing with a lot of bugs and you start addressing technical debt, and all those things start accumulating, making it a smoother, faster experience. And I've been able to measure this a lot. It is generally as fast as or faster than what people were doing before. It's just not obvious that that's the case. But for this first objection, for the person who says it doesn't even matter because we're just going to do an experiment and leadership said it's fine. We've already talked to them. It's cool. Don't worry. We know it's going to dip. We know it's going to be slower at first. It's fine. The next objection will be that TDD is just not practical. It's not practical in our environment. It's not practical in general. Well, I would say compared to what? Like, is it as practical as slinging code with looking at it real hard or manually testing every time or writing a few tests that just say it does what I hope it does and never anything else? I'm not sure that that's not more practical or not. Like that's kind of a goofy statement to me. The practical argument is more to me a statement about it doesn't seem compatible with how I work and where I work, which is going to be true. The way typical developers work, TDD is completely backwards from it. And so those two things are not compatible. They don't coexist. And so you can't make TDD work in your head the same way you also work. Something has to give, and that's why most developers reinterpret TDD to be different, is because it's just not compatible. The other side is the environment, which we'll talk about as a part of this experiment. But yeah, they're more than likely they've built a system or set of systems in a code base that makes writing tests really, really hard. That's kind of self-imposed. So TDD will, through a lot of pain and suffering, begin to address that. But I'm not going to say that it's impractical or it won't work. But yeah, there's going to be environmental issues that make it hard. But that's work, Third argument, this happens usually if the others have been exhausted, that TDD is academic only, which is sort of a cousin to it's not practical. The academic argument is either that it's only used in academic settings or it's only regarded in academic context, like in books and articles and things like that, but no one really does it. I mean, a 5-minute Google search will prove this wrong. But none of these things matter because we're doing an experiment. So, okay, we'll see if it's too slow and practical, only academic. That's fine. Last one, you'll probably never hear this, but once in a blue moon, you'll get this one. And that would be that TDD doesn't actually fix any bugs. The person who tells you this will also know what TDD is and surprise you. Compared to everyone else that I've said that will get it wrong, they won't. Now, when they say it doesn't reduce bugs, this is not a common objection at all. You'll never hear it really, but I wanted to point it out because it brings up something really, really interesting about TDD and what's going on. So the statement that TDD doesn't reduce bugs can happen for two reasons. One is that people start doing malicious compliance and doing knowingly bad work just to check a box. If that's what's going on, you've got other problems and TDD ain't one. The other thing that goes on that makes this also true, and we don't like to talk about it much, is by and large, software development or software developers in general don't really invest much in their career on developing skill sets around testing. It's a chore, it's an afterthought, it's a thing at the end we might do if we have enough time. It's not a thing they put anywhere near as much time in learning like they would with design practices, principles, and all the stuff for writing code. Testing gets almost none of their thought. And so I will say that most software developers actually have a fairly underdeveloped skill set when it comes to testing, which means when they first do TDD, they won't think of the tests to write to eliminate the bugs. It'll take everything they've got to write just the bare minimum set of tests of does it do what I wish it did, and not protect us from what it could go wrong. This is a thing that has to be developed over time. There's lots of techniques for it, but yes, in the beginning, TDD may not actually reduce many bugs because we have a whole team of people who don't know how to really write a lot of tests very well. That happens. So this one comes up, but I often either say it's going to be a malicious compliance or an admission of skill gap, which is part of it. So this is going to be a skill development issue, and it's fine. But again, TDD is this nice little self-reinforcing cycle, so it works out. We can go. Okay, so those are the objections. They're the same objections that you'll have to deal with technical leaders. But again, we're just doing an experiment. It's not a big deal. Like, we don't have to solve this all. We're not going to convince anyone. We just need to get in there and do it. So what I would say is, don't dwell on these. Just say, hey, let's try the experiment. Now, what will turn a technical person's head and make them say, you've got my attention. It's not getting rid of bugs. It's that's developers generally will say bugs are just an eventuality. They're just a reality. Bugs exist. What will turn their head, though, is this idea that TDD can actually help them with their design and making their system and code base easier to live in. That will get them interested. They may still say, I think it's a bunch of crap, but they'll be interested enough to give it a shot. And that's what we want. Now, how this happens. So making the system easier to live in happens because that sweet third step about refactoring, when we clean things up all the time, that tends to make things easier to deal with. Now, the design thing is a little bit more interesting, and it's something you have to experience to get it, but that comes from writing the failing test and the refactoring step. By writing a failing test, by what we wish was true, we tend to not to wish for things to be hard, complicated, and full of bugs. So we tend to write simple and easy to maintain code when we're in the position of writing a test first. Tends to work out that way, but if we make a mistake, we get to refactor it in a few minutes. So that's how it begins to apply this sort of like, we get cleaner and better code as we do TDD. And that will get people interested. They'd be willing to do an experiment for like, oh, that could work out. I'd be interested in that. So that's the selling point for them. So experiment number one, what we're going to do is, and we're doing just with the champion for now, is we're going to have them pick a tech stack that they're comfortable with, fluent in, easy to go. They're going to build a project of their choosing. If they don't have one, vending machine. And this is a typo, but you want to let them basically build that as far as they can for 2 to 6 hours. 2 hours if you're technical and you can sit with them afterwards and help them fill in the gaps because they haven't seen enough yet. 6 hours, closer to 6 hours if you're less technical. So they have time to let them absorb it. And then you're going to debrief. So the debriefing questions after they do their first project, the way they would do it is you can ask them how far they got. And you want to sit with them and see the code. Even though you're not technical, there are 2 things I'm going to ask you to look for. How far they get. Is there anything in the code that you're particularly happy with or proud of? What would you want to come back and clean up or fix? And if this had enough features, would you be willing to ship it? Those are your questions. And as you're looking at the code, the things I want you to look for is basically the sort of how long of unbroken chunks of code are. So I call them like walls of text. So how tall are these walls of text before they get broken up by something else? The other thing to look for is how many levels of indentation exist within those walls of text. Now, walls of text just basically that just means it's just a whole lot of statements, and that means that when you're trying to read the code, you have a lot more stuff to cram in your head because it's not split up into maybe easier to digest chunks. This would be like reading a book without chapters. And so the bigger the walls of text are, the more likely they will misinterpret or create a bug without realizing because there's just too many things at once. The levels of indentation almost always correspond in most languages to logic statements or logic choices. And that means there's a branch of what could happen. And so the more indentations there are, the more permutations of what could go wrong. And again, you don't need to say anything about this stuff. You just want to keep an eye for what sort of shapes exist. Like how big are these walls of text? How many levels deep do they tend to go? Just kind of put it in the back of your mind. Next step, we're going to do the exact same thing again. Same project, same amount of time, same tech stack, but they have to strictly follow TDD. That's the new one. Now, when you ask them to strictly follow TDD, I will tell you to err on the side of being overly explicit about exactly what that means, because most developers, again, have internalized a way TDD is that is not as I've described it to you or what anyone else would describe it as. And so we have to not let that happen, because otherwise the results will not materialize. And so I tend to be fairly explicit about it and say, so we're going to strictly follow TDD, which means you must start by writing a failing test. Then you can write the least amount of code to make it pass. Then you can clean it up, which means your first file you will open is a test file, and you will write a test in that test file first. Before anything else, that's what will happen. Then you can make it pass. Then you can create your implementation file and make it as little as you need to make it pass. But that has to be the way it starts. You start with a test. And then you can turn them loose. Now, if you get the feeling that they're not, like, you're really not sure about that yet, you can sit with them and you can prompt them and say, okay, let's start by writing a test. If they're like, what test would I write? Well, let's write a test if the thing got null, and prompt them through it. So they have to follow the motion. And then after a few cycles of it, turn them loose. We're going to debrief, and you're going to follow the same debrief questions as before. How far did you get? What are you happy with? What would you like to go back and change? And assuming it was feature complete, would you be willing to ship it? Now, there's some more questions I'll get to in a minute, but you're probably going to hear a very different set of answers between these two sets of questions. And a lot of the difference will come partially in the tone that they use, but there will also probably be some material differences. So how far did you get? They will get less far when they do TDD, but there will probably not be a, oh, I didn't get anywhere, this was terrible. It'll probably be like, well, I didn't get quite as far, but they won't be unhappy about it. They'll be happy with the progress, even though it's less. Which says something about this sort of like, how much are we really losing, you know? Now, the next one about what are you happy with? Are you proud of? In the first one, most of the time you'll hear sort of a, in the first case, you'll hear sort of like, well, you know, it's all fine, whatever, it's just code. They won't have a lot to say about what they're proud of in the first version, but in the second version, the TDD one, they may say something similar, but their tone will be a lot happier. Like, you know, I'm okay with this. I'm happy with it. They'll have that sort of tone of they're happy with it, as opposed to they're okay with it. That's the second one. The third one about what would you want to go back and change? Well, in the first version, they will probably be able to point at something that they want to go back and fix, that they're not happy with it. It's named bad, it's ugly, it's whatever, that they want to go back and deal with that. In the TDD version, they're less likely to have anything they want to fix, or it'll be much smaller. And this will be the most striking difference. Now we get to the last question. Assuming it was feature complete, would you be willing to ship it? In the first version, you'll hear all the things like, well, we didn't do code review, you know, we didn't get it tested, it didn't go through our CI pipelines, so we need to go through all that kind of stuff. You know, you'll hear all that. In the second version, you will likely hear, well, I mean, we still need to go do all those things, but yeah, it's ready. It's good. I'd ship it. Suddenly, all the things that were there to protect us from problems are now just a checkbox because they have really high confidence that what they've built will be fine. And that's a massive difference. So that's that set of questions. But now you want to debrief on the whole experience so far. You can ask, what did they notice about the TDD experience? Like, what were they doing? What was surprising as they did it, or what really challenged them as they went through it? What were their overall impressions after doing both? And what are they still curious about as they do in regards to TDD? And you can also, at this point, make a note of the walls of text and the levels of indentation. You may notice that the walls of text actually get a lot smaller and the levels of indentation start to vanish. And if you see something like that, you can point it out and say, hey, I noticed that between the two changes, you know, things seem to be a little bit shorter and, you know, there's not as many like nested logic statements. And this could be a nice way, if you notice it, to help the developer notice some of the subtle design choices that they started making that they would not have noticed or observed or paid attention to before. And this may sound crazy, but there's a lot of really small choices we make when we are writing software and coming up with design choices, and especially in TDD, that accumulate so quickly it's not easy to pay attention to all of them. And TDD works in really, really small bits. So we make many, many small changes to how we do things, and they accumulate to big results. And so doing things like, well, I've made my methods like half the size, that's a fluid thing to do when you're doing TDD, but it may not be obvious that you did it until someone points it out. It's like, hey, all that stuff's a lot simpler, smaller, easier to read. And like, oh yeah, it is. That's crazy. They don't even realize they do it sometimes. So that's the second experiment. Now, overwhelmingly, people will have a curious but positive response to this, because they will start to see some of the merits. They will see that they've started to write better code. They feel better about it. It wasn't all awful. It wasn't too slow, too impractical, only academic. Those things didn't really hold as much water as they thought. So now we need to move to the next phase. We've done it in a sandbox laboratory environment. Now we need to do it for real. So the second experiment starts. And we're going to ask them to do it on a single or part of a work item in their actual work or sprint. You don't have to be flexible about negotiating this, because like I've said several times before, there is a skill issue and an environment issue at play. And most code bases that I've ever seen or people have worked in just are not built to easily write tests against. They're built to write code in, not to write tests in. And that means they have a lot more challenge ahead. And so we need to be flexible about how much we ask them to do in this, because they may be in a really tough environment, makes it really hard. So it's okay to scope it down. We can do this again and ask for more. But so what do we do? How can we help them with this new set of challenges of working in their production code base, which was written with an incompatible approach to TDD? So there are a couple things we can do. If they are working in a bit of code that does have tests, they can start by refactoring to make it even easier for them to start their TDD approach. This is your best case scenario. Yes, and I know the last one is really small. I'll get to that in a minute. It's small for a reason. The second thing you can do if you don't have tests, this is a compromise, but it's one I'm generally comfortable with, is if their IDE can do a refactor for them, hands off, automatically, without them messing around with it, they can use that to refactor the code to make it easier to do TDD with. It's imperfect, but it's a reasonable compromise. Now, the third option always works, but man, does it suck. You just have to write the test for the code the way it is written, not the way you wish it were. And that means if it's really hard to write a test against, too bad, just got to do it. This is part of what's called characterization tests. It's really hard, but it always works. Just as a small side, the worst code I ever had to do this in, it was a 3,000 line long method, and it took me 2 weeks to write one test, just one. So when I say you need to be flexible about how much you scope on this, that's why. Now, I've never seen anything that bad. Most developers will have like a couple hours to a couple of days to put a test around something, depending on the condition. But that's really brutal, but it works. It always works. Now, the last one that's really small is really small for a reason, because I'm going to tell you it for completeness sake, but I'm going to tell you not to do it. And that is that you could feed the thing that doesn't have tests into AI and say, give me tests. And AI will happily oblige you with things that look like tests. Doesn't guarantee that there'll be good tests, correct tests, or anything else. And since most developers don't really invest in their testing skill sets, they're not likely going to be as critical of what it gets back, which means you might put in tests that give you false positives, and you don't want to have doubt in your test suite from that. So it is a valid option, and I would say as people get more comfortable and grow in their concern over their test code being as important as a regular code, that this becomes more of a viable option. But it technically is an option, but it like heavily asterisk, be careful. You could wind up with like test asking you to do the wrong thing because they're wrong. AI could be wrong and it won't tell you that it is, it just can be. So we're going to do that. That's the thing. They're going to do their work, do a TD in their work, and they're going to have a lot of problems with it because they're overwhelmingly not going to be in a good environment with it, and they've just started, so they have the skill problem and a tough environment. An analogy here would be like, does this mean TDD is not practical? And I would say it's about as practical as gardening is when you don't have good soil. Like gardening isn't the problem. You're not in the right environment for plants to grow yet. You can fix that. So you do the right things to make the soil work. So we've done that. Last step is to repeat this with the team. So we have our champion. Hopefully they see some merit in it. We just keep growing this with them. And then if they're like, yeah, okay, now we want to do this with the whole team and see what happens. Well, now you get to do the same thing. You're going to repeat the first experiment of basically having them do the project. Now you don't have to do the first, before and after. You could just start the after if you want and just say, tech stack you're familiar with, strictly following TDD, build the project for 2 to 6 hours or whatever it is, and we'll debrief. You can do that. And then you're going to move to the let's do a single work item. But now you have your champion here to help you. And they can actually dive into the code. They can sit, they can pair, they can help them navigate the choices about what test to write, how would I refactor this, all those things, because they've gone through it ahead of them. And this will alleviate some of the demand that you may not be able to help them with if you're not that technical, because they are. And so that's it. And while you're doing this, start collecting some of the metrics. If we care about speed, watch the speed stuff. It will dip for a little bit. The defect rate, you should see almost an immediate impact on that one. And so, yeah, just be honest about it. Like, here's what's happening. But if people are honest about TDD, in my experience, the results show up. It's a virtuous cycle. It tends to work out. So with that, I'm going to conclude and say thanks. This is how you can get a hold of me. I do have a weekly newsletter. You can sign up for that if you'd like. I write about this kind of stuff and other things. But for that, I'm going to turn it off and we'll do some questions.
Okay, we got a lot of questions, which is great. So let's see. Somebody said, I think for me, the hardest, I'm just going to take these in order that they're voted. So feel free to go ahead and vote for them if you want to see things in different orders. I think for me, the hardest thing to wrap my head around is using it for web apps and CRUD operations. Maybe it's obvious and I'm just overthinking it.
So if we're talking about this in terms of really basic CRUD apps that don't do anything, it can feel a little redundant. But what I would say is you still get a few things out of it. So I'm assuming it's the case of this is a really, really simple thing. Really basic CRUD, really basic show the stuff of the CRUD. Yeah, so most of your frameworks are going to be doing the heavy lifting. You don't have a lot of code. However, there is value in doing TDD because, one, it will give you confirmation you're using your frameworks the way they were supposed to be. Two, it will reaffirm that you are making sane design choices throughout it. And C, you will have a certain amount of, I'm sure it works the way I thought it did. And so you may not need to go as far because your frameworks will be doing a lot of lifting for you, but having that extra bit of confidence and certainty that you're not making it hard to work in pays off. So you may stop your TDD cycles earlier if your framework does all the work. There's also another thing too, and web stuff is a little tricky. Front-end frameworks exist in that sort of like unpleasant environment to do TDD in typically. Because they do so much of the work for you, you wind up in this, am I testing the framework, am I testing my code? As you try to do TDD, you will find a strong desire to move all of your code outside of a framework into like plain old stuff and have clear places where you do interact with the framework, which makes where your code is really easy to test. And then you can kind of let the framework do its job because you didn't ask it for much. That's a pattern that tends to exist. It's also commonly called hexagonal architecture or ports and adapters patterns. It tends to develop as you do TDD because it gives you the certainty you need on your side of the equation, but lets your frameworks do their job without commingling them. So there's a little bit there. Front-end frameworks do make it hard though.
Okay, next question. John was asking, how do you reconcile TDD with spec-first development and the inevitable code generation of objects? I'm facing this battle quite often.
Like spec-based as in a formal definition up front that you have to comply to?
A JSON schema. So they're going to API design, spec-first design, where they design the JSON schema, and then they want to generate Java objects from it. How do you test drive that out?
Well, that's where you have a framework doing all your work for you.
Yeah, it's ridiculous in my
You
opinion.
don't need to test your framework. So I would say don't test the framework, but do set a boundary from where the framework ends and your stuff begins. And that's where you would put your tests. So if the business and everyone has decided that we will bet everything on this generative thing that will take a JSON file and crank out objects, great. You still need to know that all that stuff worked correctly and interacts correctly. So that's where you start to do your stuff. Like, let it do its thing. I would put the test on the other side where now I have to use the thing and see
But
how it plays out.
what they're generating is the endpoints, right? That I need to test, and I want to use TDD to test those endpoints.
Yeah, so you're moving your testing up and out. So you may not have, this is where we get into some stuff about like, people get kind of twisted around sometimes around like, well, TDD means unit tests. And I have no such conviction. TDD is just write the test you need to write. So
Exactly.
if you have a tool in place that is generating everything up to the endpoint, then test at the endpoint. Then you know, and that's a contract test, and that's fine. You know, if you find that there are issues with that, then I would start to look at seeing where you need to untangle some stuff to get a little more certainty. But if the closest place you can test without testing against testing the framework did its job is the final endpoints, then that's where you start. And at least you have the contract in place to say, we got what we thought. The framework did its job. We got what we thought. That would probably be how I would do it. And it can be a little bit crappy because now you have the full integration to deal with.
Okay, thanks.
Yeah.
Okay. Yeah. Good question, John.
Yeah.
Okay. Are comp sci students currently being taught TDD in schools?
I have from the folks I've worked with, I'd say it varies quite a lot from being aware that it exists to formally using it, at least in some class. But I'd say that's about the spectrum I've seen. Code boot camps, I have not really seen any of them do this on any level or really address testing at all. But I think it's at least academically addressed in computer science curriculums. Whether or not people leave with any practical experience or understanding or encouragement to do it, couldn't tell you.
Most IDEs include test language example, the should in your example. Or, oh, I'm sorry.
Oh.
Do most IDEs include test language such as the should in your example?
There are two basic styles for writing, for test writing. There are more than this, but generally speaking, there are going to be two that you deal with a lot. One is what we would call an X unit, N unit, or J unit style test, and that's going to be like a test class with a test method. That's what a lot of like C#, Java, that's what they'll default with typically. I don't tend to like those. I find that they are not as expressive as I would prefer. The other type of language, and you can find things to do this in just about every language, it's just not always as easy, is sometimes called a BDD or spec-based language, and that's what you saw me use. I tend to like it because I feel like it's just more expressive, more natural, and easier for me to organize things. That's how I work. But it doesn't mean I take a big poo-poo on people who have to use like traditional unit testing. You just get in there and do it. Like, to me, I'd say try them out, see what you like. I know what I like, but I'll take whatever I've got available if I can.
Do you need experience or be good at writing tests before you try TDD? Are there any prerequisites?
Nope. That's kind of one of the best parts about why I think TDD is a great practice for non-technical people to approach, is because TDD will basically, as a part of its feedback loop, give you good feedback on the test you missed. And so you will naturally start to learn what test you should be writing over time. There are other things like the zombies acronym and some other things to help give you some sort of cheat sheet about I should be thinking about things when I write tests. But you can just start with the test that you can write. And my guidance is try to write one more after that. Stretch yourself to write one more, and you will slowly but surely begin to develop those testing muscles.
How hard is it to introduce TDD to a project that already has a lot of history and existing code? You kind of touched on that, but somebody else was asking.
It really, it's harder for sure. And so because most larger projects or existing projects, and it's just the industry thing, most developers write code, they don't really write tests as much or write their code to be tested as well. It's going to be an uphill battle. How uphill, I can't say. That really varies, but it will be harder. But that's where I kind of would say, like, the approach I've outlined sort of helps with this. Okay, we can see TDD work in an easy way where we don't have anything working against us, and now we can slowly bite off doing it in an environment that is less nice to work in. And that's where those refactoring techniques that I mentioned come into play, because you have to address the environment issues before you can make reasonable progress. And it's valuable work, but it is hard.
What do you say to managers or executives to encourage TDD for their developers?
So I basically would say, and this is maybe not, people don't really like it when I say stuff like this, but here's the way I kind of look at it. I would say that managers and executives who want to encourage TDD need to be really honest about what it means to do good work at their company. And most of the time they just leave it up in the air. And so they leave it up to every developer to decide what's good, what's not. And so if they have a strong opinion about what quality looks like in their code and tech, then they should define it. And then it's on TDD to meet it. There are plenty of ways to meet good standards. TDD is one of them. But most places have pretty loosey-goosey standards. They may have a clear process, but loose standards. And I would say, before you start asking people to do TDD, ask what good looks like. And then say, try TDD if you need help figuring out what to do to achieve those standards. That's typically how I would approach it. And so I have worked with teams where we've done like defect-free work, where that was a standard. We do not accept defects anywhere in our process. They're not allowed out. And I had teams like try to figure it out their way, and they couldn't. They tried TDD, and they were actually able to use TDD and a few other things to ship defect-free code for years.
Awesome.
So I focus on the what does good look like, and then TDD becomes an option.
Awesome. Just one random thing I want to mention, kind of vein of on the educational side and also getting people to start. There is a school of thought kind of around how to code. University of British Columbia uses it. Northwestern recently used it. They're switching some stuff, but they were very much of the line of getting the students to think through, give me an example of how you plan to use this. And they didn't even call it a test. They just said, give me an example of how you would like to be able to call this thing. And
Yeah.
then we'll code, which is doing the exact same thing. But for some reason, telling people that you're writing an example of it was able to get over a hump that they weren't able to do if you were telling people to write a test, at least with students. So that might be another tool to try sometime.
So to that point, there was a really old article written by, why am I blanking on his name now? Oh, that's embarrassing. Anyway, he basically described this approach, and he did it with students, and he said, we're going to build an email system, but there's some rules. And the rule is you can never ask anyone a question about what they do. You can only tell them what to do. And they had little cards that they could write down what they were told to do. And then at the end, basically you got to watch everyone just walking around telling people what to do, and they would go tell what other people needed to do. And through people, we're able to basically define a system only by telling each other what to do, never asking each other questions.
Interesting.
And it was all done by intent. And I found that to be just a really awesome way to conceptualize like that kind of concept. But TDD puts you in that boat immediately, just by frame of reference. But that was also about the tell, don't ask principle specifically, and why getters and setters are not good and stuff like that. But whatever. Okay. I think it's the same.
I'm gonna have to look that up. That sounds very interesting. Well, Ryan, thank you so much for coming. It was very insightful. I always have high expectations for your talks, and was definitely not disappointed. So, and from the comments, it looks like everybody else was getting a lot out of it too. So, thank you so much for taking the time to share. And like I said, everybody, we're talking about engineering fail, or how to fail in a successful way next week. It might be something fun to bring your teammates to if you like hearing about horrible engineering failures. Be interesting. But Ryan, thanks again, and hope to see everybody next week.
Take care.